Yeah, I can hear you guys.
Yes, yes. So I'll give a quick introduction about Rajeev Dwivedi, sir. So, hello everyone. Today we have with us Mr. Rajeev Dwivedi, an alumnus of mechanical engineering. He's from batch of 1999. He'll be sharing with us his rich experience and struggles of making his mark in the industry and establishing himself as a leader, followed by his thoughts on the career opportunities in robotics and competitive robotics, and wrapping up with a small question and answer session. So he's currently working with Amazon Robotics in the US offices of Seattle. He has 25 years of technical and leadership experience in the industrial automation and product lifecycle of large electromechanical systems industry. He has been awarded master's and doctorate degrees from Southern Methodist University. He has a two, he has since continued to work with Siemens for 7 years with a 5-year tenure in FinServ between his two terms at Siemens. He has also held the position of adjunct professor at his postgraduate alma mater. The quality of his research and innovation doesn't need an introduction, as his 25 works published in journals, conferences, and white papers speak for themselves. His zeal to innovate has landed him with 5 US patents and 4 applications till date. We are proud to watch such feats of achievements by our alumnus, bringing fame to IIT Guwahati. So, without any further ado, let's hear from Mr. Dwivedi.
Okay. I think Anmol is trying to call me on the phone. Let's
Oh,
see.
I'm sorry.
That's fine. Okay. Yeah. Thank you for the introduction, and so nice to meet you all. And it's great to see the way institution has grown. And um, I'm from the I'm from the first batch. In fact, I was the first general secretary of IIT Guwahati, and it was yeah. I have seen like the institution being built right in front of us, and we started in a temporary campus in Guwahati city itself, and later on we used to go to the campus. I mean, we never got to live on the campus actually, but we used to go there on buses for classes as well as lab works. So from there, so much growth, so many departments, and so much of accomplishment. It's really great. It's been a long time, and great to be associated with the institution. So uh, after finishing my undergrad at IIT Guwahati, I will give you a brief introduction of my journey and few words about the competitive robotics, and then after that, I will answer your questions. Okay. So after graduating from IIT Guwahati, at that time, uh, the natural path for most of the people, especially like me, who were coming from lower middle class, like path to the better way of or like better life was joining one of the software companies like TCS, Infosys, and Wipro. But I was really passionate about the field of engineering as such, especially mechanical engineering. So even uh, okay, It- can you guys hear me all right?
Yes, sir, we can hear you.
Okay, so actually, so while obviously being the first batch of any institution, we did not have any big brother to guide and tell us like what
Welcome
I
to my
and
world.
actually, pardon?
No, sir, it's the
In
speaker.
mode.
So I would say that turned out to be pretty good for us because we went on uh, not following the established norms, and we started reaching out on ourselves to various research communities as well as various industries. And our faculty members were also quite young at that time, so there was a lot of cooperation from them as well. Not saying that I'm sure like faculty will be very cooperative and helping in your ventures now also, but at that time there wasn't much of age difference between us and them, so there was a lot to learn, lot to explore. So at that time, I myself was personally very passionate about the field of robotics itself. So one of the professors who was from Bhabha Atomic Research Center, he connected me to a scientist there, and that opened a lot of opportunities for me. So I went and worked there for a summer, and I took that opportunity like in the best possible manner. Uh, Talked to pretty much every scientist, see what was going on, and many of them were actually very supportive of this. They made some of the latest literature in the field available. They introduced me to one of whatever is happening latest in the field of robotics at that point of time. So, well, after graduating, I didn't want to join that crowd of like mechanical engineers, chemical engineers, everybody joining these software companies to develop a software for bank, whether you like it or not, just for the sake of a big paycheck. So that was sort of difficult for me, a difficult decision because obviously coming from a lower middle class family, as soon as I graduate, I'm expected to support my parents in some way. Uh, but luckily, even my parents were quite supportive about that idea. They said, like, okay, you got just one life, pursue it. You should live your dream. So one of the professors at that time, he had joined from Thopper Corporate R&D, and he introduced me to the Thopper Corporate Research and Development Center. It was the corporate R&D for Thopper Group of Industries, which include Crompton Greaves India Limited. Uh, so it was not easy to get in there, but I was given an opportunity there. Mr. Anmol, you are calling me again.
I'm sorry,
Okay.
sir.
No problem, no problem. That's fine. It's all right. Okay, I'll put it in mute or okay, that's fine. Not a problem. Don't mind. So and then for me, working in that lab, unmarried young person, with like dreams in the eyes, it was like a candy shop for me. There was a lot of resources available there. So I at that time one of the well, okay,
So I think it's a glitch. We are stop calling him.
okay, no problem. Maybe I don't know if it is mistake on my side or what, but I put it in the silent mode now. Okay, so no problem. Okay, so so while I was there, one of the emerging fields was the computer aided design. So I helped with the industrial complete design automation, the Crompton Greaves India Limited, and similarly Greaves India Limited. I helped them with the design automation process, where at a click of button you can generate at least 80% of the manufacturing drawings. At the same time, one of the well-established robotics companies in United States called EOA Automation, they contacted us uh, while I was at Upper Corporate R&D to design some of their robotic with tool changers. So uh, that is how I got in touch with the person who had found that company. His name is Keith Crawford. So So between me and Keith, we tried to form a small startup company. So for 3 months, we had pretty good success, but that is when the major crash came, and I really wanted to like pursue more of more on the intellectual side, and I really wanted to do some research in the field of robotics itself. Wanted to know what's going on, so I applied at Southern Methodist University, and I got an opportunity to work with Professor Kovacevic. So that lab is called Research Center for Advanced Manufacturing. So at research- it is one of the biggest concentration of additive and subtractive processes under one roof. So that is where true industrial robotics started for me. So I integrated a laser-based direct metal deposition end effector on the robot. I developed uh, solid freeform fabrication processes where you could, I mean, even for overhang, like in the 3D printing, usually if you are building an object or you're fabricating an object which has overhanging regions, they typically need support. So we had a project from NASA where they wanted to fabricate parts in space. One of the key things was you don't have gravity to aid. So uh, and in addition to that, like typical plasma and other processes, they cannot be applied there. So um, we had to come up with a very novel approach, a very novel way of fabricating the parts. So we integrated a metal deposition head with a six-axis robot. I developed a process where you can add material from any direction. And in general, actually, even when I was at IIT Guwahati, as well as uh, when I was working itself, I mean, I read pretty much all the literature which I could get my hands on. Uh, uh, I understood a lot of things. I did not understand a lot of things, but in general, I got a very good idea of what are the real challenges to be solved. So when I went for masters and PhD at SMU, I was really well prepared. So again, that will be a very that is something I would like to share with you all. I know many of you want to go for higher studies. That's a great idea, uh, but I would strongly recommend like you make yourself familiar with the problems to be solved, because even some of the most well-established names in the field of academics, they are, irrespective of everything, they are still not so well connected with the real problems that have to be solved. So as a graduate student, you go there, and about 4 to 5 years, you are trying to identify a very interesting topic, and then you identify a topic, and uh, somewhere the frustration starts to come in, like wow, my friends are making such a so much money, they're forming startups up, and I'm still here in a school and not with no end in the sight. And then the desperation hits, and you pick up any topic somehow you want to finish, and then you come out with a PhD or master's degree with not a significant body of publications to help you. So if you are giving your best part of your life, which is your youth, to something, try to get best out of it. For me, I did not go with the preparation, but I would say I was quite lucky because I got exposure in industry, and in general because of the interest also. So I had really good idea of what are the problems that are waiting to be solved, and that way, uh, I mean, it is a it for the lack of right term, I was able to negotiate with my advisor that okay, like uh, I will help this lab establish itself and as one of the leading manufacturing research labs, and I will with the but I would like to finish my master's and PhD as quickly as possible. So within 4 years, I was able to finish both master's and PhD both, and that even with about 25 to 30 publications, and that helped me establish myself in the field also. Uh, then, so while I was at the lab, also for me, the key thing was uh, uh, what I did was like while most of the people they pick one topic and keep on going for investigating deeper and deeper. Since I came from industry, I knew all the problems to be solved. So my my thesis was actually compilation of uh, the solution proposed for various problems. So one chapter had got nothing to do with another. It was pretty much like that. But with that, I was able to create the seeds for the research for all those who came later in the lab. So even though I've been working in industry, I work very closely with the Research Center for Advanced Manufacturing. So if any of the students want to pick up one of the topics which I initiated and want to take it to the next level, I work with them for it. taking it the next level. So after that, I started working for Siemens Energy and Automation. Uh, there was no pure robotics there, but there was significant automation there. So we made machines for sorting packages and letters, uh, and so I worked in the field of high-speed video-based analysis and a lot of sensing, as well as kinematics. And then I went to the semiconductor industry, which is Finisar. So Finisar is one of the leading manufacturer of optoelectronic devices. And so if you have heard of this, when Cisco and Google, they go and claim that we are offering a transceiver that can transmit all the movies ever made in Hollywood in 10 minutes. So that was based on uh, the technology of which I'm one of the co-inventors. And even on the Apple phone, the new 3D gesture recognition system, I'm one of the co-inventors there. And I was also involved with the process, developing the processes for it. And while at Finsar, I was surrounded by this great physicists and Nobel Prize winners. But again, I wanted to move to the next opportunity. So within Finisar, know, there was a lot of there was a lot of opportunity for intellectual growth, but as a career, uh, like what I was looking for, I didn't see there a lot. So I came back to Siemens, and then after Siemens, uh, at Siemens I developed machines for logistics, which is like you know which is supporting all this in shipping industry, where the packages they come in a truck and they are dumped in a warehouse, and these robotic equipments they pick and place them, sort them at almost like 10,000 parcels within an hour, and they're on their way. And then I recently, actually, yeah, last year I started working for Amazon Robotics, and there I'm working on the various technologies which are we are developing technologies for which will be relevant 10 years from today, which includes, the drone-based delivery, uh, like very high-speed manipulators for sorting packages, and depending on the address, depending on the sizes, depending on the form factor. So yeah, it has been great. And for me, yeah, I like this field. That is one of the fundamental thing. Well, one thing I suggest everyone, and one principle that I go by is you got just one life. So whatever it is, do the kind of thing you like to do. I mean, be an engineer if you love to be an engineer. If you want to be an artist, try to be an artist. Okay, or within a field of engineering, I love to be a mechanical engineer. And the same thing I would also suggest, like it should not be driven by their desire for bigger paycheck or anything. It is like what you want to do. So quickly I will say few words on I don't know if that's what the typical format is, but anyways, I'll try to bring this whole conversation to a conclusion by a few more words. So, in addition to working in the field of robotics, I also work with the children in school here and prepare them to compete in various competitive robotics events. And I'm also co-founder of World Robotics League, because what I have come to learn and what I have come to believe is future doesn't necessarily belong to very smart or hardworking people. It belongs to the people who have that entrepreneurial mindset. So our generation saw emergence of that, and your generation, well, there's not a lot of difference probably between you and me, but still, like everybody wants to build a company within an organization. Success depends on entrepreneurial kind of mindset. You go to your superiors, you go to management, and you tell them, hey, give me $20 million, I will form a group, and give me these engineers, and I will be able to increase the efficiency in the process, or I will give you a new product. So it is all over the place. So my involvement into this competitive robotics has been driven by that, to inspire the young generation to, to get a taste of it in a very controlled and forgiving manner, where, they see these problems which sort of look impossible. They are given the basic training, and they are then, a very unfamiliar context is given to them. So they apply those learning, and at the end of this, they are really able to see that, okay, there was a problem which looked almost impossible to solve, but uh, here is a solution. We came up with it, and there is a diligence process for it. So so through this process, they are able to see, they are able to, that whole mindset, or like, uh, and the whole way of working, it becomes a stronger, like, that yes, I can come up with an idea. I may not know it, but I know where to find that information. I know where are the resources. I know whom I can bring as a team to be able to deliver this particular solution within a specified time. So I have trained teams that, I'm one of the most successful coaches here within state uh, within the state of Texas. I recently moved to Seattle, so Texas is sort of useful for me. Uh, I've taken them to world championships, and many of the kids I've worked with, like, 10, 12 traders, their inventions have translated into various patents. So yeah, that's something about me. And I had some PowerPoint presentation about competitive robotics, but I think this should be good in my opinion. Okay,
Yes.
so uh, anything on this before we get to the question and answer session?
Yes, sir. So about competitive robotics, we have heard about the challenges which Amazon and Google have also done in
Okay.
make humanoid robots, and so how do we get into these kind of competitions?
Okay. So read about them. Read about them. Try to understand every aspect of it. Here's one thing that many people misunderstand, and that is, wow, all the innovation is happening in United States. You have so many resources. Not really. It is. Uh, I strongly believe it is. I mean, and it is not like, one. It's not preaching. That's the truth. It is. Uh, as long as you give it due diligence, as long as you, mm, like, you try to understand the problem, you are really passionate about it, you will always find a way to solve. You will always find a way to get involved into those. Okay, you'll be surprised how many resources and how many people will become available to help you. Okay, but again, like, you should be very clear about, you should have really good understanding of the problems that are to be solved. Okay, and obviously, learning and your own research has to go with it to some extent. Okay,
Yes.
I don't know, did I answer your question, or
Yes.
okay? Okay,
So we will start the question and answer session.
okay, okay, let me.
So from the audience, if you want to ask any question, you can. Yeah, yeah, please, please come forward. Or if you don't know, then यही बात है. Hi, sir.
Hi, hello, how are you?
So, how was the time at college different from industry? The research life different from industrial problems?
uh I mean, yes, to some extent, exactly what I mentioned earlier to you. So, so wherever you go, like, whether you go in the field of research, whether you go in field of industry, uh, your intellect, your opportunity, what your parents have done for you, all the sacrifices they have made, you have to value that. What why I'm saying that is, like, go really well prepared. Don't go like, okay, let me join this path and we will see what comes. So go with certain expectations. This is what I really want to accomplish. If I go in the field of research, this is what I really want to accomplish. So if you are well prepared, I mean, first of all, like, both the fields will be very fruitful. And there's a uh, yeah, you have a lot of flexibility, like, when you go to a typical research environment in an industry, sorry, in a university or a lab, versus what you have in industry is quite unforgiving for that matter. Like, you have, not only you have external competition, you have internal competition as such, because everybody wants to rise, climb that ladder. So many times that whole, the idea of mm, like that whole notion of purity, it just disappears. Dog eats dog kind of situation, where when we come to the come to the university and other places, what happens over there is, yes, I mean, there are very knowledgeable people, there are very motivated people, but again, uh, what happens is, because of uh, I mean, some of the key challenges that are key problems are still confined to the field of industry. So you are quite limited in terms of, like, the kind of field or kind of ideas that you will get access to there. So if you go, the more passive you are, the least fruitful it will be. So the more active you are, you already identify a problem, you already see, like, you already have a somewhat good understanding of how the, like, where the future is pointing to, and go and take an initiative on that. And your advisor or your, the research peers, they will certainly support you, because then you become a path for their growth. So you will have easy access to the resources. uh, uh, and yeah, but in general, like, the research environment in general in university is quite forgiving, and that way, even if you do mistakes, you won't be penalized. Actually, you can generate a research out of your mistakes itself. Okay, this is not how you do things, you know. Okay. I don't know, did that answer your question, or or everything you had? Okay. Okay.
Anybody else?
Sir, so are you suggesting that we should work in the industry for some time and then go for masters and PhD? Uh,
uh, I mean, if well, uh, not really. I mean, if you get uh, uh, that will be very helpful. First of all, that will certainly be very helpful in really understanding the problem. But you can prepare yourself really well. It's in general, there is so much information available. We didn't have Google. You guys have Google. So uh, uh, you have access to the latest and greatest journals. I'm not saying, like, go and start looking at the reading the whole papers. Just start reading the abstracts in general, like, IEEE Spectrum, or the ASME magazines. Just go read the abstract. That will give you an idea of what's really going on. So if you feel at some point of time, well, I mean, um, I'm going to invent something that is going to change the industry. By going in industry, then go to industry, or I know what I have to do. Let us find a good college, good university where you know, I can relax and research, generate a good name for myself, and establish myself as an authority in the field. So you can take that path also. But educating yourself and being aware of, I mean, it gives you that whole control on your own destiny. Otherwise you throw yourself at the mercy of, your boss in the industry, or your advisor in the, if you go to any of the universities. So go well prepared. You should really have good understanding of, like, what you want to do in the life. uh, what are the problems you want to solve, what are your expectations. Okay.
Thank you, sir.
Any other questions?
Yeah.
One of the question we have got on live chat. Uh,
Yeah.
the question is, if I want to go for a field that has not been well established yet in robotics, how should I pursue my higher studies?
Oh, okay. Uh, uh, Sorry, I think I heard the question, but can you repeat it again? I mean, can you repeat it?
Sure, sir.
Yeah.
Question is, if I want to go for a field that has not been well established yet in robotics, how should I pursue my higher studies? What should be my choices?
Okay. So, I mean, there are two aspects to it. I mean, if it is a very novel kind of field, a path not many people have walked, it comes at, you know, it can go either way. In terms of a career choice, you might be the first person to do it, and you might be the Google, you might become a Google, or you might have to wait for a decade or so before people really understand what you are trying to build. It's like, the Tesla brought their electrical cars, uh, long time back. At that time, market wasn't ready to accept it, so they had to go through that whole process and then came back. So I would suggest is like, talk to the talk to people in the industry who are pretty close within that field. Talk to your professors who are working somewhat closer in the, within those fields, and what where you differ from them, where you have your own opinion about it, share it with, both the class of people, and see, what they suggest. So that's what my suggestion would be. So the preparation, and talking to, I mean, we understand that it may be a novel field, but if you go to US patent office website, I mean, you think of any crazy idea, you type it there, there'll be a patent for it. So what I'm saying is, like, despite the novelty of any idea that you might be thinking, certainly somebody, somebody from industry who may be somewhat close to that field, or that line of research, that line of development, as well as in academia, you will find someone who may be able to answer you few questions that will help you. I mean, it is difficult to get, like, life in general doesn't give you all the answers. So we'll have to, but you will get a point to start that way. Okay?
So, if there are any more questions, we'll pursue further with the questions we got in the form.
Okay, let me open the upon
You
my.
know, but I'll repeat. What kind of applications have you implemented robots for? So,
Okay, so okay, let me open the questions up here. So I have developed robot for manufacturing processes. So within manufacturing processes, not only form factor. What is? Wait, there is an echo here. Just a second. I think there was. Can you hear me clear, or there is this echo? Let me take this speaker out here. Can you hear me now? Yeah. Uh, So uh, we wanted to take the whole 3D printing idea to the next level, where not only we wanted to make a highly conformal surfaces, and highly conformal and freeform shapes. We also wanted to control the composition of material from one point to another. So we integrated robots along with a special kind of end effectors, which were based on lasers or electron beams. So that I did during my PhD, and then I used the robots for assembly of optoelectronic devices. for 25 gig uh, communication transceiver, as well as uh, for the assembly of gesture recognition systems. And now I'm making the robots for the logistics industry, where loading and unloading, packaging, sorting. Uh, I make mobile robots for those applications. Yeah, that's what I'm doing now.
So the next question is, what were the major challenges you have faced or seen people face in the industry?
Okay, so for me personally, I really didn't have a good GPA. I mean CPI. Okay, so that closed a lot of doors for me. Okay, but again, I was really driven, and so let's start with that. Okay, uh, but in general, I'm very innovative and creative person, and actually my CPI annual, it was reasonably okay. It's just I was while I was in IIT Guwahati, and so many resources available. So instead of chasing CPI, or I should get 10.0, I really wanted to learn. I really wanted to know. So I had that kind of respect also. I had earned that kind of respect as well. So I had a lot of support from faculty as well on that. In fact, while I was at ITG itself, I made the first speech control robotic vehicle there. Uh, I mean, those were very early days, like when we had. I was a mechanical engineer, but I learned 8085 programming. I made I mean, I learned the principles of pulse width modulation to control the speed of motor, and I implemented everything. So anyway, so yeah, I was really driven in pursuit of what I wanted to do. After that, what happens uh, is the it is not most of the people are able to enter in the field that they have prepared for or they have degree for. Okay, so that is one place where I faced a difficulty, because robotics as such is, I mean, it is perceived in many different ways. Wherever you go, everybody has a different definition of it. Uh, so what whatever was the closest available to me at that point of time, which was industrial automation. I mean, that is one significant component of robotics itself. So I took that opportunity and made the best out of it. And from that point onwards, I was able to uh, move my career to, the pure robotics, for the lack of right term. So yeah, but that is one of the things, it's um, when we train ourselves, we go to the graduate schools, we go to the best universities, prepare ourselves, hoping that when I graduate, that is the particular field I will get to work in. But life is not like that. Opportunities don't come that way. Okay, so within available opportunities, whatever is the closest to your passion, closest to what you want to do, you pick those. And after that, you try to, within your capacity, gauge your, or establish your career so that you can get to what you always wanted to do.
So the next question is, what should be the approach to pursue robotics as a career, given the lack of higher robotics courses in the college, except an introductory?
Okay. Okay. So again, I'll go back to that, what I had mentioned earlier. It's in fact, uh, the kind of intellectual environment, kind of support that you have at an institute like IIT, uh, it is totally unparalleled. It's very difficult to get that sort of thing even in United States, because here the mode of selection and everything is, uh, I mean, it is very different. The criteria for selection is very different. I mean, you guys know all the physics and chemistry and maths principles inside out. Here, within like at the undergrad level, even you go to MITs and CMUs and UT Austins. I mean, undergrad kids are really, they don't have as much knowledge as you guys. So carry on that whole how when you went to the way you prepare to go to IIT Guwahati or like IIT as such, just maintain that and like continue to explore, learn and read and get to know what's happening in the field in general, and it will prepare you really well. And anyways, at undergrad level, what you do is you get a taste of everything, you know uh, uh, you get a taste of everything. At that point, I mean, beyond that point, that's where you start to delve deeper into the field and start to make inventions and discoveries. So that's what my suggestion will be. Rather than waiting for a an awesome course or instructor to come and teach you or and inspire you, take that onto yourself. Like go and obviously, like that is certainly one thing. You should take those electives, take those courses which are close to it. But at the same time, like I'm sure you will have access to at least IEEE spectrum. You will have access to IEEE industry. I mean, robotics and automation. The magazine that comes. Just go and read, see what's going on, what are the latest thing happening in the field. In fact, pretty much each of those journal papers have the email address of the authors who have written that. If you find something interesting, you can communicate with them and probably build those personal relationships. You can tell them, I'm excited about this, I'm very motivated, and maybe they might open the next door for you. So that's what my suggestion will be.
So the next question is from a chemical engineering second year student.
Yeah.
What is the scope for chemical engineers in the field of robotics?
Okay. Okay. So robotics has two sides. Okay. One side is the solution, and other side is the problem. Okay. So if a robot has to, a robot can offer a solution that's awesome, but what is the problem that you have to solve? So, yeah, I mean, chemical engineers pretty much dictate like a lot of requirements for many robots. The robots which are used in chemical industries itself, uh, like where you have to mix two components in certain ratio, and there's requirements are extremely stringent, as well as say think of the food industry itself, where you have to add certain things in certain proportion, as well as like the like within the chemical industries where the environments are not as conducive for they're not so safe for human beings. You use robots there. Okay, so you define the problem side of the robots, and actually that can be your path for uh, path to robotics. And actually, one of the latest things that is happening in field of robotics is like making the manipulators, making various end effectors at nano and macro levels. So those mechanical engineers can only dream of, like what will make it happen. It's the chemical engineers who can come up with those like really awesome processes, how to etch MEM-based device on a silicon wafer that can behave like a SCARA robot or an articulated robot. So that is, I mean, that is pretty much the field of chemical engineers.
So the next question is, what are your thoughts on non-conventional bots, like you mentioned, these nanotechnology and soft robots, or those with non-conventional motor parts?
Yeah. So I mean the products, people's expectations, everything is changing so fast. And what happens typically in, I mean, by robotics in general, what is perceived is a highly configurable machine that can be applied to various fields. But there are a lot of fields, for example, medical robotics, or like in handling a special kind of material. So they need very a specific kind of drives. They need very special kind of actuators. So certainly, like, within the field of robotics, there is one entire field where things are being developed specifically uh, to cater to that particular industry. So non-conventional motor parts, soft robots. Uh, there's a complete field for that actually. So yeah, that field is also growing. Uh, think of it like, what you have on a cell phone today, that kind of electronics. About 10 years ago, like, putting that kind of electronics with, uh, you have a complete modem there, you have a wireless antenna there, you have a speaker, you have a video card, you have a display, interactive device, all those things. Like, it would be at least, 1 cubic feet of electronics 10 years ago. But now all these things are possible because of those very non-conventional and very like this novel kind of robotic implements. Yeah.
Sir,
Yeah.
there is a recent hype about machine learning and reinforcement learning. So, what are your thoughts on, like, in the field of robotics, on the application of reinforcement learning in the
Okay.
industry?
Yeah. So yeah, certainly, like, it's um, there. This has the whole field of AI, and everybody's trying to make self-driving cars. uh, I mean, uh, that even though self-driving cars probably will be possible in 10, 1 to 2 decades from today, but it has opened up a significant possibility. It has given very valuable tool in to industry as well as field of research as such. So instead of, like, developing uh, processes, developing a way of doing things specifically to solve a problem, now we use, like, machine learning, or we have a lookup table that we build up so that we don't have to take decisions like, if A happens, if B happens, if C happens, and a part of D happens, this is what I should do. So you take out all that, the computation part, and all you do is, like, make a reference to a lookup table essentially. So uh, at the same time, one of the fundamental things, one of the basic or most important problem associated with heavily automated systems is that uh, they have to be able to deal with very varied kind of situations. So as a human, when you are developing those systems, you can certainly expose your equipment or your system many different kind of scenarios, but still there will be one scenario in which that equipment will not be able to take a decision. So by extrapolating understanding, like, understanding of existing scenario, finding a combination of both, many of those, adding weight factors, that's what essentially, like, AI and machine learning inculcates or enables. So uh, like, industry initially was hesitant, but it has come to accept it as a very valuable tool. And in fact, a lot of products are being developed. Not, certainly in the field of robotics, but pretty much in every field. As taking it all the way from uh, like, equipment that solve the problem, assemble components, all the way to like, social media itself. We are using these kind of things. Yeah.
So the next question is, what is the future of robotics, and do you vision the development of personalized robots as the PCs have become in the recent 2 decades?
Okay. So, certainly, like, robotics as a not only as a field, robotics as a philosophy itself. I mean, robotics is as such a philosophy also. What it means is, like, bringing all these things together, like the mechanical implements with the smart algorithm that gets its information with the help of various sensors. It all comes together. So certainly, in fact, as a students, as like the scholars in the field, we have to start developing that mindset right from the start. We cannot close our eyes to, okay, this is where I draw the line. I will develop this algorithm because I'm a computer scientist or a computer engineer, and you take it from there. So, mechanical engineer to some extent has to understand, uh, the principles of computer science and algorithms. They have to understand, what are the limitations and capabilities of the control systems. So, um, so it all comes together as a robotics itself. Uh, so that in terms of philosophy, in terms of the physical thing as a robotics, yes, I mean everything is shifting towards it. All these novel implements, such as one example I gave was cell phone, and uh, all those things have been possible because of robots. Robots not for automation itself, robots for accuracy as such. I don't know. I mean, if you pick up one of the old PCBs versus if you see the new PCBs, the old PCBs, yes, you can imagine a human being assembling those chips on that PCB. But if you see the PCBs and electronic surface mounted devices today, and the pitch or the density, you just can't even imagine that human being can do it. So it is the robots which have made it possible, and they are they are the way to go. They are the future. So there's pretty much everything will be robotics. That's what I can say. Uh, uh,
So
yeah.
the next question is, uh, what is the demand and supply ratio of robotics professional in India? Means the job opportunities in India for robotics. What is your opinion about it?
Yeah. So I mean, as of now, I mean, from what I heard, there are a lot of high-end electronics companies, coming to India. Actually, a lot of high-end electronics which used to go to other parts of the world, China, Japan, all those things are coming to India. They are really driving the demand for, those professionals who understand that sophisticated manipulation of, for assembly purposes, for manufacturing purposes. So, there's there, in my opinion, there the demand is growing, and certainly it will continue to grow. At the same time, one great thing about our country is, uh, we got a taste of it now. We have become super ambitious, and we want to make the rockets. We are making Chandrayaan. We are sending, you know. those spacecraft to Mars now. So, and we are also getting very ambitious about, developing the latest and greatest technologies. So, robotics will be a significant component of it. So, there is going to be extensive demand. Uh, uh, I mean, probably, I mean, for the people who know robotics, as well as, people who know the way of robotics. In terms of supply, uh, that is a little bit sad state, I would say, because most of our universities, they, in my opinion, they should focus a lot on, hands-on, because hands-on is not about developing a skill. It's really not about developing a skill. It is more about getting an appreciation of it. I mean, in fact, you work with machines, and then you know how many ways that machine is limited, and that opens the door for, what, this machine is selling for 1 million. I can make a machine with better capability for 500,000, and that's an opportunity for you. So, in my opinion, uh, yeah, I mean, closing that gap is a little difficult at this point of time. So we need to do a little bit more to train those professionals. But again, I mean, that's that opens up a lot of opportunities also, like the people who have who are looking at the opportunities and preparing themselves.
The last question from our side is that what are the opportunities of summer internship, research, or directly job for undergraduates at Amazon Robotics?
So Amazon Robotics is very open actually to accepting interns and letting them work. It's just that what happens is, like, since Amazon as such is like, they are very focused on future centric technologies. So they are very selective about the people that they choose. Most of the time, what they have in mind is like, person they will take as intern probably to hire, because they don't want anybody to walk away with all the technical know-how. But again, if everybody likes smart people, and again, when there are a lot of opportunities, so look up for it. I mean, if you see something in Seattle area, certainly you can reach out. I'll try to talk to those managers and see, like, if we can get you, if we can get you there, or within India if there are like, centers, and I'll be glad to forward your resume over there. Yeah, so there are opportunities a lot. I mean, yeah.
So there is one more question from the audience.
Sure.
What are the challenges now in the field of robotic manipulator as a mechanical engineering, which we can work on it in the research area? Robotics manipulator.
Can you come closer? I could not hear that clearly. Come. Sorry, my apologies. Yeah. Okay.
I'm asking you about the challenges now in the field of robotics manipulator as a mechanical engineering, which we can work on it in the research area.
Okay. So manipulators. Some of the things that you can look at is more of. I mean, so material handling is certainly one field. I would suggest, like, the end effectors, like, typical end effectors, they are very fixed directional. So if you can think of manipulators, like, uh, and with a significant degree of freedom of manipulation, that will be I mean, industry really needs those kind of uh, really need those kind of manipulators and actuators. Yeah, it's uh, for example, I will give you an example of Amazon warehouse itself. So Amazon warehouse may have many conveyors, they may have many robots, but what happens is, in the same shipment you may have you know few books that have arrived, you have SD cards that have arrived, you have like, bag of candies and a shampoo bottle, all these things. So if you can if you can think of a manipulator that can handle a very wide range, both in terms of form factor as well as the wide range of material, I mean, then you are the king. Okay, so yeah.
Yes, sir. So after all these questions, we have reached to a point where we have to close this event. So thank you
Okay,
Dwivedi, for your
thank you.
giving us
Okay,
your time, and I'm sure we'll be keeping in touch with you.
sure, feel free to write to me. Okay, good luck to you all. Okay, bye.
Thank you. So I stop the